Hello friends, I'm Bob. In this video, I will be showing you the solution to the Maclaurin series of cosine inverse x using the formula shown in the top right hand corner of this video. But before I start working on the solution, if you guys like this video, help me press the thumbs up icon below this video. Basically, a function can be expressed as an infinite series as shown in the top right hand corner, the formula, in which my f0 is the function evaluated at x equals 0. And then we have f prime 0 is the function differentiated once and evaluating x equals 0. We then have f double prime 0 is the function differentiated 2 times and evaluating at x equals 0. And f triple prime 0 is the function differentiated 3 times and evaluating at x equals 0. And we have f 4 times prime 0 is the function differentiated 4 times and evaluating at x equals 0. For this particular problem, we will be expressing the Maclaurin series of cosine inverse x up to and including the x to the power of 4 terms. We express the function of x to be cosine inverse x, and then we will start working on finding the f prime x, which is differentiating the function of x one time. We get the following. This is just negative of 1 over the square root of 1 minus x squared. Next, we will work on finding f double prime x. How do we go about doing this? Is we will basically just differentiate f prime x, which is the negative of 1 minus x squared to the power of negative half. And then we get the following: negative of negative half 1 minus x squared to the power of negative 3 over 2. Differentiating 1 minus x squared, we get negative 2x. Then we will simplify it by cancelling here in this manner, and hence we will just have negative x 1 minus x squared to the power of negative 3 over 2. After which we will find what is my f triple prime x. So this is by doing the product rule of differentiation. First, keep the negative x, and then we differentiate 1 minus x squared to the power of negative 3 over 2. We get the following, which is negative 3 over 2 1 minus x squared to the power of negative 5 over 2. Differentiating the inside, which is 1 minus x squared, we get negative 2x. And then we work on the second part of the product rule of differentiation, which is differentiating negative x, we get negative 1, and then we keep just 1 minus x squared to the power of negative 3 over 2. And hence we get the next set of answer. After simplifying, we get 3x squared 1 minus x squared to the power of negative 5 over 2. Now, of course, we have a negative sign in front, and subtracting away 1 minus x squared to the power of negative 3 over 2. So now let's work on next the f4 times prime x by differentiating f triple prime x. So for the first term itself, we will apply the product rule of differentiation. We start off by keeping my negative 3x squared, and we differentiate 1 minus x squared to the power of negative 5 over 2. We get the following, which is negative 5 over 2 1 minus x squared to the power of negative 7 over 2. Differentiating 1 minus x squared, we get negative 2x. Then we will apply the second part of the product rule of differentiation. For the first term, we will differentiate negative 3x squared, we get negative 6x, and then we keep 1 minus x squared to the power of negative 5 over 2. And then as for the second term of the f triple prime x, we will just differentiate it. We get the following, which is negative 3 over 2 1 minus x squared to the power of negative 5 over 2. Differentiating 1 minus x squared, we get negative 2x. And last but not least, we will simplify the terms, and we get the following. For the first term, we get just negative 15x cubed 1 minus x squared to the power of negative 5 over 2. For the second term, it's just as it is. And then as for the third term, basically we have the following. It's just negative of 3x 1 minus x squared to the power of negative 5 over 2. So once we have find what is my f(x), f prime x, f double prime x, triple prime x, and 4 times prime x, I can substitute x equals to 0 into the following function. So I substitute x equals to 0 into fx, basically it just equals to cosine inverse 0. So cosine inverse 0 is basically pi over 2. How about f prime x? So for f prime x, substitute x equals to 0. Basically, we will have just -1 because my denominator is 1, so -1 over 1 is just -1. For f double prime 0, substituting x equals 0 into f double prime x, basically we have 0 because my numerator itself is 0. Anything times 0 is equal to 0, so we have 0. How about f triple prime 0, substituting x equals 0 into f triple prime x? So for the first term itself, basically it's 0, if you can work it out. And for the second part, it will just be equals to -1 because we have 1 over 1 times -1, we have -1. Last but not least, f 4 times prime 0 is basically 0 because all three of the terms itself are 0. So we have now f0, f prime 0, f double prime 0, f triple prime 0, and f 4 times prime 0. I can apply the formula shown in the top right hand corner of this video to express the Maclaurin series of cosine inverse x up to and including the x to the power 4 terms. So hence we have the final answer, cosine inverse x is approximated to be, first thing, my f0 is pi over 2. Then for the second term, which is my x times f prime 0 is basically just -1 over 1 factorial. For the third term of this series, my f double prime 0 is 0, so we do not have the x squared terms. As for the x cubed terms, we substitute f triple prime 0 as -1 and we get this answer. And last but not least, f 4 times prime 0, same thing. For the x to the power 4 terms, we do not have it because my f 4 times prime 0 is equals to 0. My final answer to this problem expressing the Maclaurin series of cosine inverse x up to and including the x to the power 4 terms is basically just pi over 2 minus x cubed over 6. If you guys liked this solution, help me press the thumbs up icon below this video and do consider to subscribe for more Maclaurin series problems. I'm Bob, thank you guys for your support and I will see you in the next video.